Hi, everybody. Welcome. Nice to see you, or at least you to see me. Here is going to be your lesson on 5-1 trigonometry equations. This is a quick little introduction because these are going to get very complicated. We're going to be adding factoring and square roots and a whole bunch of stuff that you're going to have to remember, and we'll definitely practice those. But the first thing I'm going to do is I'm going to do a warm-up. So I'm going to be asking you to attempt to solve these three problems. So the video is going to pause for a second here and ask you a question about these, but I'd like you to try to solve them on your own. So as the video pauses, try to solve all three of them and then answer the question, and then it'll pick up right where it left off. So as you're doing this, the very first problem you encounter here, part A, is you need to solve for x. So to get x alone, you're going to subtract 5 from both sides. You're basically undoing an equation by undoing. Please excuse my dear Aunt Sally, or PEMDAS, however you think of that. When you undo an equation, you go backwards. So you get rid of the add and subtracts first, and that's why I decided to get rid of the plus 5 by doing a minus 5. So x squared becomes 5. And then after that, you're going to have to get rid of a square. So the way to get rid of a square is to take the square root of both sides. So that'll cancel out your square. So then you get x equals the square root of 5, and that's your answer. But whenever you take a plus and minus, you need to remember, whenever you take the square root of a square, you need to remember your answer entails a plus and minus for that problem. So then for part B, you just do your good old subtract 1. And you're going to get x over 3 equals 9. And then this is a division problem. So to undo division, you're going to institute a multiplication to both sides. So multiplied 3 and divide by 3 undo each other. And you're going to get x equals 27. Now, those first two shouldn't have been too bad. You probably did those in Algebra 1 and Algebra 2. C, you probably just did for a very short time in Algebra 2, and that's using and undoing an exponential function, and that's E. And E is a number. It's approximately 2.718. So basically, this is 2.718 to some unknown power plus 3 equals 5. So it's got to be 2.718. Well, if you do 2.718 plus 3 equals 5, that's going to be like 5.7, or 2.718 plus 3. That equals about 5.7. So I bet that exponent's going to be under 1. So let's just see how we do this problem. Same thing like you did before. You subtract 3. And now the question is, do you remember how to get rid of that base of E? Well, the base of E is going to be gotten rid of through something called the natural logarithm. That's an L and an N. There's a button on your calculator for that, ln, and that'll cancel this right here, and you'll get x. But if I do that to the left side, I need to absolutely do it to the right side. So ln of 2 is my answer. Now, ln of 2 is decimal, and I plugged it in my calculator. It's roughly around 0.69. And that kind of makes sense to this problem. 2.178 to a number less than 1 will draw that 2.718 down a little bit. So those are my three answers. Excuse me. So now the thing I want you to notice about all these as you did this warm-up is you're solving and you're trying to undo operations. So if we were in class together, I would ask you, how do you undo a plus? And a lot of students would say minus. How do you undo a square? A lot of students will say square root. That's no problem. This is definitely the trickier one because when you studied inverse functions in Algebra 2, you really should have talked long and hard about how to undo exponentials, specifically E, and you do that with a logarithm. So this is about undoing and getting things alone. That's how you solve any equation, and you've been doing that probably since about 7th grade. So then when we get to this, we had a little introduction to this in last class. We are basically saying for this problem, the secant of what degree measure or the secant of what angle measure equals 2. Now, sometimes you're going to be able to know exactly what this is without doing a lot of work, just maybe thinking back to your unit circle or your purple sheet. But you also need to know, what does secant mean? Well, secant means the reciprocal of cosine. So if I change this to cosine x instead of secant x, remember the s goes with the c, then if I do that, just change it, well, I have to do something to the 2. Because I used a reciprocal function, the 2 becomes a reciprocal. So it changes to 1/2 because it was 2 over 1. And cosine is the reciprocal of secant, and secant is the reciprocal of cosine. So if I change it, I need to do the reciprocal. So then the question stems from, well, what is the cosine equal to 1/2 if I go to my unit circle? Because that's one I should know. So there are 3 in this first quadrant, and the cosine being equal to 1/2 is the one that goes right there. So that's going to be pi over 3. So x is pi over 3. Or if you were in degrees, that would be 60 degrees. Now, like the last few problems, we had a bunch of symbols for how to undo things. For example, when I see the symbol of plus, I deal with it by instituting a minus, because that undoes it. They're inverse operations. When I see squares, I undo it with square roots. When I see e's, I undo it with ln's. When I see division, I undo it with multiplication. This has the same thing going on. I'll do the cosine one, and it's the same thing with the secant, but secant's a little harder to understand. So the question is, how do I get rid of this COS with what kind of operation? Well, just like someone decided a long time ago, undoing a square is going to be this symbol here, what kind of symbol undoes cosine? Well, there's 2 that are acceptable, and here is one of them. It's called the same thing, cosine, but it's got a little -1. It looks like an exponent, but that's called an inverse function. So that's what will cancel this side. So then if I put a cosine -1, which means inverse cosine to this side, I'm going to need to do it to this side also. So that's the mechanics behind how to throw something new in here that gives you an answer. And then you just need to know that if I'm ever asked a question like this, cosine inverse 1/2, it means the cosine of what equals 1/2. The answer to that is pi over 3 if you're sticking with radians. Okay, so that's example 3. So we're going to kind of go through these 2. There's a couple things that I want to talk to you about. And the first thing is the variable x that I have in this first one, I can use x's all the time whenever I want to. But I could also use, instead of an x, I could use a theta. Or I tried something new here. I'm going to use a beta. So a lot of times Greek symbols are used for unknown degrees. However, variables like x can be used for those too. That's why we have an x. So just like in regular math, you're going to try to isolate the x, or in example 5, the beta. Now 4 doesn't have the tangent alone. So we're going to have to really get that tangent alone by dividing by 3. So that leaves us with, I'm going to put a little arrow over here. I'm going to try and isolate these problems. I'm running out of room and I'm writing on my very small laptop here. So then I get tangent of something equals the square root of 3. It's okay if you decide not to use this little inverse notation, but I'm going to, because that inverse notation is going to be a separate problem later in this chapter, and we'll talk about it when we get there. So I want to keep doing it for now, just to get you used to it. So I do that little tan with a -1 thing to both sides to cancel that. So my answer is x equals inverse tangent of the square root of 3 over 3, which means the tangent of what equals the square root of 3 over 3. Now, and you can probably look at the back of your purple sheet, but I always get confused with the tangent because I always don't know which one's the square root of 3 and which one's the square root of 3 over 3. So I'm going to do a little side note here by doing the 31. And if I don't get the right answer, it's the 61. I know that tangent of pi over 4 or 45 is 1. So this is clearly not 1, but I remember square root of 3 over 3 being one of those tricky ones. So I'm going to start by attempting, okay, let's just real quickly do a little work on pi over 6. So tangent is sine over cosine. The sine of pi over 6 is 1/2. The cosine of pi over 6 is radical 3 over 2. So then I could change this to 1/2 times 2 over radical 3, and then those 2's cancel. So I end up with 1 over radical 3, and if I rationalize the denominator, it is the square root of 3 over 3. So that's the right one. So then I know that my x value is pi over 6. We're going to stick to radians on these answers. All right, so then the next one, example 5, is something that I don't recognize, 8. 8 is not on my purple sheet. It's not on the back of my list. So I'm going to grab my calculator and I'm going to say, okay, I don't really know what it is, but I'm going to guess some things. So if I'm guessing like tangent of 1, so if my beta was 1, what is the tangent of 1? Is that 8? I don't know. I hit tangent 1. Now I get 1.55. So it's not 1. How about the tangent of 2? Ooh, 2 is a negative. It's tangent. If I put a 2 in here, it's negative 2.18. Oh, that's not helpful. What could it be? 3? Tangent of 3? So this is a weird one because if you think of tangent's graph, all this comes back to graphs, looks like this with an asymptote at pi over 2. I wonder what pi over 2 is. So if I do a decimal, pi divided by 2, I get 1.57. So this is 1.57. So I know that a tangent of 1.57 is undefined. So I jumped from 1 to 2, but I bet it's like really close to 1.57 because 8's way up here somewhere. So no, remember when tangent shoots up like that? So I don't know. Let me try 1.5. Tangent of 1.5. I get 14. So I'm close. So tangent of, 1.4. 5.7. So it's between 1.4 and 1.5. Tangent of 1.45. Around 8.23. So my beta has a radian value that's roughly close to 1.45, but I'm still not there. I wonder if there was an easier way to do this. To be continued. All right, moving on. So remember, everything goes with the unit circle, and I want you to take a look at this graphically because I only gave you one answer and there's multiple answers. So the question is, well, where does sine equal 1/2? Well, if you look on the unit circle, it's right here. That's where sine equals 1/2, but there's multiple answers. Where else does sine equal 1/2? Right here? No, that's -1/2. Right here. So any time sine is a y value, you hit this y value right here that equals 1/2 along this horizontal line. So notice how that horizontal line intersects the unit circle, and sine is the y values, so that's a height. Then you're going to have an intersection. Interesting. Well, what happens about secant? Where is the secant of x equal 2 square roots of 3 divided by 3? Well, change this one into cosine for me. Can you do that? Let's see. Now, first of all, why did I pick cosine? I picked cosine because cosine and secant are partners. They're reciprocals. So reciprocals mean reciprocals. Now, I really don't know if I know what this cosine of 3 divided by 2 times the square root of 3 is, but if I rationalize the denominator, maybe I'll have a clue. So if I rationalize the denominator by multiplying by top and bottom by square root of 3, my numerator becomes 3 square roots of 3, and my denominator is 2, and the square root of 3 times the square root of 3 is just regular old 3. It's a square root of 9, but it's regular old 3. You get this, and hey, lo and behold, the 3's cancel. So even though it didn't look anything like 3 over the square root of 2, when I flipped it, and you look at the green part there, it is. So when is cosine equal to 3 divided by the square root of 2? Well, that's the same spot. But now there's another one. Well, where's that other one? Remember how sine, I had to draw this horizontal line? But that's negative. So no, that's not it. So in this case, I'm going to end up drawing a vertical line. because this is the other spot where cosine equals positive square root of 3 over 2, or secant equals 2 square roots of 3 over 3. Just remember to do reciprocals, but I wanted to show you how this looks graphically in case if you have to do that again and draw in a line that intersects the two answers. Remember, cosine and sine and tangent and secant and cotangent all have two answers. So the lines, if you ever connect the two answers, the lines will be horizontal for sine, vertical for cosine, and tangents are odd. So like if I asked you where is the tangent equal to 1, you should know this one and this one. So those tangent lines go like this. That'll come into play later as we move forward. So here's the next one. So this question is, this little symbol here is undefined. I could use the word undefined if I wanted to, but pause for a second here and try to figure out if you know where the tangent is undefined. Hopefully, you know that's an asymptote. Hopefully you have it memorized. So if you think about tangent, the graph looks like this. I hope you know where these asymptotes are. They are at pi over 2 and negative pi over 2. And then there's another one way over here somewhere, because remember, tangent repeats cyclically like this. And the other one is going to be another pi over, because tangent has a period of pi, so it's going to be 3 pi over 2. Okay, so now why is that? Because tangent is sine over cosine, and whenever the cosine equals 0, doesn't matter what's on the top, you get an undefined. So when is the cosine equal to 0? So I know a lot of this, a lot of you have, but cosine is equal to 0 right there, 0, 1. And here. All right, so a lot of this is thinking through the unit circle, but you're thinking through it backwards. So then I've got a couple more to do real quickly for you here. This is just good old regular sine. So what you're going to be doing is you're going to be isolating sine, get it alone, and then trying to use that unit circle process to figure things out. So I'm going to subtract 3. I get sine of theta equals 4 minus 3 is 1. Just for funsies, I'm going to use that inverse sine again, but I'm going to actually use a more modern version, because a lot of times in the past, a lot of math people said, well, that looks like an exponent, and it's not really an exponent. So then that symbol was changed to actually be this, arc sine. Latin root word of arc means to undo. So arc sine. So that's just another thing I'd like you to see in case if you see an arc question on an ACT or a college entrance test. So to get rid of sine, you could do inverse sine or arc sine. Both sides. So then theta is going to be the answer to arc sine of 1, which means where is the sine equal to 1? Everything goes back to the unit circle. Right here. 1, 0. Nope, that's cosine equals to 1, Shapleski. It's here. 0, 1. So theta is going to be pi over 2. We're going to try to give our answers always between 0 and pi over 2 if possible. And if we can't, then we'll kind of go and extend it to like pi, because there are hundreds of answers that the sine is equal to 1. There's millions, because you can keep spinning around. This one doesn't work. This one is negative 1. So there's really only one in a full spin between 0 and 2 pi, pi over 2. But if you go like 2.5 pi, 2.5 pi, that's a full spin plus an extra half of a pi. That's still going to be at the same spot, still going to be 1. So we'll always try to put these between 0 and 360 and 0 and pi over 2 if you can help it. All right, here's another one. Good luck. Give it a try. See what you come up with. Step 1, bring over the 3. Step 2, before you do this inverse tangent thing, you have to get rid of a square. So how do you get rid of a square? You square root it. So the tangent of theta is equal to the square root of 3. However, Don't forget, just like in algebra, whenever you take the square of a square, you need a plus or minus. So now, when is the tangent equal to the square root of 3? Well, if you remember from earlier, the tangent is equal to the square root of 3 over 3 on this one. And then this one here I know is 1. So it's got to be this guy right here, that big guy right there. Okay, so that's it. So then that's going to be, theta is going to be that guy, which is pi over 3. However, there's negatives here too. So I'm going to give all answers from 0 to 2 pi. So every answer I can give you, I'm going to give you in one full turn. So it's that guy. It's also this guy because tangent would be negative in that quadrant. So it's also 2 pi over 3. It's also this one, and it's also this one. Remember our bow tie method? All of these guys have the same sines and cosines, and since tangent is sine over cosine, they're going to have the same tangents too. So 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now there can keep going if I want to, but I'll list those. All right, so now that's basically your lesson for today. Your homework is going to be on 5.1b Delta Math. Do your best. If you finish all of this, feel free to check on Skyward to see if you're missing anything while I'm gone and try to get that taken care of. Thank you for coming today. Have a good day.